Okay, so let's talk about what imaginary numbers even are. So I'm going to start by writing this equation, x squared equals -1. Do you know any number, any real number times itself that would give you -1?
Not off the top of my head.
Yeah, it's impossible. If we took 1 times 1, we'd have +1. If we took -1 times -1, we'd have +1. There is no real number that when you multiply it times itself that gives you a -1. So what mathematicians did is they invented a new type of number where you could multiply a number times itself and get -1. So that's where imaginary numbers come from. They said, let's make an imaginary number I that when you square it, you get -1. So when we work problems now, anytime we see an I squared, we can replace it with a -1. So let's go over to question 14 now. We have -1 minus 2i minus this parentheses. Now, when we have minus a parentheses, there's an understood 1 there. It's a really a -1 that we're going to be able to distribute throughout this set of parentheses. So if I take -1 times -3, negative times negative is always positive, so that gives me a +3. -1 times 7i would be a -7i, because negative times positive is always negative. And then we still have the -1 minus 2i sitting here from our first set of parentheses. And now we can go ahead and simplify, and you just treat the I as a variable if it's just an I. Now, if it's an I squared, of course, you replace it with -1 and you simplify farther. And anyway, I see a -1 plus 3, so that would be a 2. And then I see a -2i minus 7i. -2 minus 7 goes even more negative. That's going to be -9i. And now we do have it in the form a plus bi, where we have the real part plus the I part, the imaginary part. The real number a equals 2. And the real number b, which is the number in front of the I, would be -9. What questions do you have about what I did there?
That kind of makes sense. Can we do one more, like maybe the 16 where we divide it?
We can do more. We'll just go in order. I'll do number 15 next.
I have a question.
Yeah, go ahead.
So for number 14, we were just discussing. So if it's always so in between the parentheses, if there is a negative, it's always -1.
It's assumed to be a -1. If there
Okay.
had been a plus in between, it would be a +1, which isn't going to change any of the signs. So if it's a plus in your parentheses, you can just drop the parentheses. But if there's
Okay.
a negative in between, you got to distribute your -1 throughout before the parentheses disappear. Okay, so now we're going to evaluate this expression. We have the square root of -6, and square root always takes, that stands for the principal square root or the positive root, and you always get a positive real number out of a square root, but we wouldn't get that. We've got a negative number under our radical, and it's impossible to do that in the real number system. So we're going to rewrite root -6 as the square root of 6 times the square root of -1. And likewise, the root negative 3, we're going to write as root 3 times root negative 1. And our root negative 6 we'll write as a root 6 times root negative 1.
Why exactly are we doing that?
The reason we're doing that is that you can replace the square root of negative 1 with I. Because remember, we consider I to the second power as being negative 1. We take the square root of something, we're trying to think what times what is that number under the radical. So we can replace that with I. So we'll rewrite this whole fraction, replacing the root negative 1s with the letter I. So we've got root 6 times I. And in the denominator, we have root 3 times root 6. So I'm going to multiply those together. That gives me a square root of 18. And I have a root negative 1, which we're going to consider to be I, times I. I times I is I squared. Now, it might be tempting to cancel out your I and your I squared, but you can't do that. When you have an I squared, you need to replace it with negative 1. Same way over here. It might be tempting to cancel those I's out here, but you don't do that. First multiply them, get your I squared, then replace the I squared with a negative 1. And now another thing we can do to simplify here, we have a root 6 over a root 18. So we can simplify that and put it all under the same radical. And 6 over 18, we still have the I here. We still have the negative 1. I squared is negative 1. But the 6 over 18 now we can simplify as 1/3. The square root of 1 is just 1. So we've got 1 I in the numerator. And in our denominator, we have a root 3. And root 3 times negative 1 is a negative. Okay, now we're supposed to write this in the form A plus BI. So we want the I part at the end and the real part at the beginning. So we'll write this as negative 1 over root 3 is the real part.
Because I is negative 1.
Plus I, 1I is the imaginary part. This negative we'll just put with the root 3 and write it as negative 1 over root 3.
Where do you get the negative 1 from again? Because the I is assumed to be negative 1.
I is the same as 1I. 1 times I is just the same as I. So, well, wait a minute. No, you're right and I'm wrong. Let me erase this on that step. It's not plus, it's times. Okay, so to put this in A plus BI form, we'll put 0 for our A value minus 1 over root 3 times I. So our A value is 0 And our B value, the coefficient of the I, is -1/√3. And let's double check our answers here. Okay, they turned it into a decimal, so let's divide that out. We got the negative part correct.
Yes, it's the
5
decimal
seconds.
form.
Yes, we got it. Did it tell us to put it in decimal form?
So if we would have wrote it the way you wrote it, would we have gotten that wrong?
I
Because it
don't
expected
know.
decimal.
If they counted it wrong, you would just email me and I would give it back to you. I would
Okay, got you.
either format. Typically, I tell people to put it in the fractional form unless they say otherwise. So, yeah. This is what I would have expected them to want. I'm going to look at the beginning of the assignment and see if they say anything about that in the overall instructions. They do not.